Hey, Alex, they're all sitting down. They'll be here in a second. Created. Passing out stuff. Cole, Bailey, Nokai, Abby. Whoops. Oh, Abby, I just passed a paper to you and it went all the way over.
Take that. Now Ozzy's eating it. Dang it. Cole, you sit up here.
Ivy's not here.
What is this?
Michael.
What is this?
I have no idea. Hi, no Ivy. Cole.
This. Why did her guy? Oh, it's cold.
Did you see Abby's on the floor? It shut all the way off the table and kept going. So. Okay. Got it good enough for now, I guess, huh?
Hey, Cole's up here.
All right, guys, come on ahead and we'll just deal with that later. We do have online people waiting. Yes.
Did you see the email I sent with my labs?
Probably. When did you send it? I'll put them all.
It was 2 labs in one.
Okay. Did you send it the other day or?
I sent it.
All right, Michael.
2 weeks ago. The day of the book.
I put them all in a file to deal with at one time. So. I don't know why it's really tested. I don't know why it's doing it.
You can play Apex, right? Okay. Or Valorant. I'm like one or 2 good games away from ranking. I just got promoted. So. Yeah, I got promoted. I got promoted yesterday and then got a win. It was like a 30-2.
What are you doing? Here, I don't care. I'm in Subway. It makes me so jealous. I don't know why.
He has Subway every week.
I know.
Okay, so this week. Hi, Bob. You want to come back up here in my lap? Come in. Hey, Ozzy.
Public subject.
Come in.
Insanely good.
Come on. Okay, here we go.
We don't need it only for the subs.
So I'm going to leave this up first. All right, so here's the thing. So you guys have this blank form, and Alex, I meant to attach it to the assignment. I did just a bit ago. So this is the form here that we're going to want turned in for this lab. 1 per team, 1 per person if you're online. So what we're going to do is, although there's a video that goes through all this, I just wanted to show you guys the calculations and how I got to my answers. Interestingly, those of you using thermometers were getting numbers similar to mine. And those of you that were using CBLs were getting much higher numbers. So basically, once you have all your data and you get ready to answer your first question here, you have your delta T, right, which is your change in temperature. So my delta T was 6.9, then 5.0, and then 11.0. And that's going to go on your form that I just gave you guys, the form. And then, no, you don't need that. Yeah, that's it.
Oh, you want the delta T on there? We just put the 2 temperature.
Well, it actually, yeah, that's fine. As long as you've got them there. And you're going to end up needing it for later, I think so. Okay, so then it asked us starting temp, that one we did. Okay, so the mass of the liquid in each reaction. So how do you find the mass of the liquid? Well, you're going to use the standard mass of water for that, which is what? Anybody know?
No.
Okay, so it's 1 gram per milliliter. So end up with 100 grams, right? 100 grams of water is what you use. And then, so it's 100 grams in each reaction, if you measured exactly. And then how much heat was released? So here's the series of equations that I went through up here on the screen. So you do the delta T for 1, which is the 6.9 in my case. And then you use the heat, which is the mass times delta T times specific heat of water. So that's 100 grams times 6.9 degrees Celsius times the 4.180 joules per gram degrees Celsius, which is up there. And this is all in a video, so you can see all of it. It's all going to be available to you. And that's how you get your kilojoules. So that's for each one. That's what I got. And then with my data, there was not enough heat to cause a burn in my case. Did anybody have anything different, or is it looking like it was going to be different? Because the highest temperature I got was the, what was it? 31 in my case. So that being the case, I didn't get anything hot enough to cause a burn.
I didn't.
So yeah, some of you got 38 or 39, but did you get 40? Okay, so when you look at, there's a chart here that I've included on the form, and that tells you, and even there's no 40 on. 48 for 5 minutes that would give you a burn, but you'd have to be exposed to 48 degrees Celsius for 5 whole minutes. And this dude's saying it was instantaneous. So he and right in the head.
Liar.
So, yeah, not a good dude, not an honest dude. So anyway, that's sorry, that was up because I was opening my internet and there it was. So that's what you guys are going to want to look for when you're turning in your forms. Just, it'll all be there. You can access it online, and hopefully that'll help you follow along. So let's look at your lesson. So what we're going to do is we're going to go over your lesson. This is your last regular lesson until next semester, because next week is all review, right? So we're getting somewhere. Taking a while, but we're getting there. So last time we talked about entropy. This time we're talking about enthalpy.
What?
Enthalpy. Mhm.
This was 2 Wednesdays ago. I remember that.
This was, yeah.
I
Remember.
thought it was enthalpy first and then entropy. We just did entropy.
Yeah, entropy, and then this is an enthalpy.
did
Oh,
entropy.
we did enthalpy, and now we're doing entropy. What did
I was
I
about
say?
to have a heart
Sorry.
attack. I was like,
Yeah, we went-
so does this count as a brownie point?
No, I just need my head screwed on tighter. So sections 3 and 4. Hey, stop, buddy. It's okay. All right, so enthalpy and entropy. Such fun words, so similar. Good times. So your changes in enthalpy during chemical reactions. Stop. So changes in enthalpy accompany reactions. So remember that enthalpy changes can be positive or negative, right? You can have something that gains temperature or loses temperature, right? So we were talking about this, I was talking about this with the younger group earlier when we talked about order in a system. All right, so when you're talking about how orderly a system is, and you think about the way a solid is constructed versus how a liquid functions versus how a gas functions, and the way the particles move. As you increase your energy, you also increase your disorder, right? Because it takes more energy. Each phase change has additional energy. So there's more energy in a gas than in a solid, and that being the case, there's also more disorder. And if you think about it, the particles are bumping everywhere with the gas, right? So obviously there's more disorder. So enthalpy changes can be positive or negative. Temperature impacts enthalpy change. So often reactants and products are presented in equations as standard thermodynamic temperature. So you probably saw standard thermodynamic temperature, which is the absolute measure of the total internal energy of an object or objects, namely its kinetic energy or energy of motion, plus other factors and stuff. So we're talking again about how the particles within a substance are moving, right? So if they're moving faster, like in a gas, as in a solid, they mostly just kind of vibrate, right? I'm putting him down. So if you have a lunchbox on the floor or something like that. So if you have a gas, obviously you're going to have a higher temperature because you've got more movement in the particles. That's also more disorder and more energy. So we express standard thermodynamic temperature in kelvins above absolute zero. And your typical thermodynamic standard state is normal lab conditions, so 25 degrees Celsius. Now, what was pretty much everybody's starting temperature for their liquids today was about what?
17.8.
Oh, was it 17.8, 18.9? Mine was, when Drew and I did it the other day, it was 19. So that tells you my house is colder than your average laboratory, which is just fine by me.
That
So-
23 seems to be the odd one.
Yeah,
No.
yeah. So sometimes you're gonna hear standard temperature and pressure.
There's
And
one
they'll-
below.
How do they abbreviate standard temperature and pressure is what?
STP.
Right, so that is not an automobile thing in this case, right?
It's not the little.
It's not the Motorola. Mhm. All right, so this is interesting. Here's a little history bit for you. See that crazy picture? So.
Is that a dog?
It is a dog. So calorimeter studies of Regnault, 1880 to 1878, combined the measurement of heat production and gas exchange by small animals in an inverted bell jar of the Hales gun barrel design. Dude stuck little puppies in a bell jar.
Then what?
A eudiometer was used for gas analysis, and heat production was determined by immersing the bell jar in a constant temperature bath. This was the first experiment to directly equate carbon dioxide and heat production in the same animal. So your reaction of aerobic respiration, which is what happens at the cellular level, aerobic respiration, not like full body respiration, that actual process produces heat, which is why you're warm, and carbon dioxide, right? You breathe out carbon dioxide and heat is a product of that. So ta-da, there's your little dog who proved that carbon dioxide and heat were coming from the same source. And if you think about it, when you talk about photosynthesis and cellular respiration or cellular aerobic respiration being opposite chemical processes, so we're producing heat. Where's that energy in photosynthesis? Where's that?
Fun.
Yes, it's coming in from the sun. And in our case, it's going out as heat. Very good. So calorimetry is experimental measurement of enthalpy, which is what we did today. So a calorimeter is an apparatus for measuring the amount of heat involved in a chemical reaction or other process, which we could make out of 2 foam cups if we wanted, but we had so much more fun with a little special thingy thingies over there. And there are different types of calorimeters. So we have 2 main types. There are different ones, but 2 main types. So there's the adiabatic calorimeter, which is used to measure runaway reaction, heat generated by the sample under test. It causes the sample to increase temperature, fueling the reaction. The other is an oxygen bomb calorimeter, which are used to measure things such as combustion reactions. So which kind did we have today? The bomb calorimeter or the adiabatic? Adiabatic, I cannot speak today. Which one do we have? We didn't have, did we measure combustion? So we didn't have a bomb calorimeter. Now the bomb calorimeters, they do, yeah, I know. The bomb calorimeters, they actually use for like nutrition information. So that's kind of fun, if you ever wondered. Because if you look at, so a calorie is a measure of heat, right? Right, cool. So a calorie is a measure of heat. And if you look at anything you're eating, like this says 50 calories. What is that? How does that translate to you? Like
50 degrees Celsius.
No.
50 units of heat.
50 units of heat that you will produce
Yeah.
in digesting that, right? So that's where the concept of calories come from. So if you're not gonna burn that energy, you're not gonna be able to burn that energy, then those calories are just gonna get stored, right? Converted. So Hess's law.
Are you trying to teach class?
Yeah, just a little. Just waiting for you to quit the crunching.
Yeah.
So here's our dude Hess. I got a picture of him. There he is. Fancy dude. Isn't he fancy? Look at his double-breasted suit. I love all these guys, man. So the change of enthalpy in a chemical reaction, or for example, the heat of reaction at constant pressure, is independent of the pathway between the initial and final states, right? That's the whole idea of Hess's law. So when we were looking at it today, so the change of enthalpy in a chemical reaction, that's what we were measuring, right, is independent of the pathway between the initial and final states. What does that mean? How do you interpret that? Do you guys remember the video from last week's lesson that I had you watch? And there was a Ghostbusters car coming down a hill, and he used an example about the brakes. Do you remember what he said?
Oh.
What did he
That's what
say?
he said, yeah.
Yeah, what did he say? Does anybody remember? He talked about it being a state function. Enthalpy is a state function. But what did he say about the pathway? Do you remember?
Isn't it the shift between the easier pathway to travel and the harder?
And that it doesn't matter, basically, it doesn't matter how much, well, for example, if you have to brake down that hill, right? Your brakes are gonna heat up. He used that example, remember? So where is it actually? Where's that? Let me find that piece. Where did I put it where you can find it? I'll find it in a minute. Because it's worth looking at that again to make sure that it's a really good analogy. So here is the overall enthalpy of a reaction is equal to the sum of the individual steps of the process, right? Which makes sense. All right, so here's what we have. Oh boy, that's fun, right? Look at that. Anybody want to try and translate it?
Not in particular.
So wait.
So what's the delta H?
I can't read it. Oh, no, I wrote that
Change in
down.
enthalpy.
Yep, change in enthalpy.
H delta S, G.
What's RXN?
Reaction.
Reaction. Good. Okay. So then what's that big, looks like a letter E kind of. What is that? You know what that is? It's a sigma. What does it mean? You know? Sum. There we go. So it's the sum of what? What do you suppose this means? N delta H of the products.
I can't remember what.
The enthalpy.
It's the sum, yeah, the sum of the total change in enthalpy of the products. Right, there you go. So it works out to something that looks kind of like this. That's another interesting little graphic. So you've got, well, hang on, I'll show you this next one's better. Maybe not. Whoops, let me go back again. Sorry, I clicked too fast. So you got reactants and products, and here you have delta H, which is your enthalpy, change in enthalpy. And then it talks about the individual elements right here. They have their own change in enthalpy, right? And they should be the same as the whole reaction. So if you were to do the individual parts of the reaction, it's going to equal the total, right? That's the concept, which I think is pretty obvious. Like if you took 3 plus 5 over here, and then you took 5 minus 2 over here, 3 plus 5 is 8, and then what I say, 5 minus 2 is 3. So 8 and 3, you get 11 on this side. You're going to get 11 on this side, no matter what. All right, order and spontaneity. So here's entropy. So a measure of the disorder of a system. So which state of matter is the most ordered?
Solid.
Right, and the least ordered would be
Gas.
gas if we're talking just standard, normal 3 states. Okay.
Otherwise, it's plasma.
There you go. So it's a thermodynamic property. It's joules Kelvin, and we abbreviate it with S. So our delta S of a reaction, so our change in entropy of reaction is the entropy of the products minus the entropy of the reactants, which makes sense, right? You take whatever you end with and you subtract what you started with.
Which I believe also makes entropy a state function.
Think so, yes, I'm gonna double check that, but I think you're correct. Yes.
Can you define what it means by disorder?
So disorder, okay, it's a
Randomness.
complicated, yeah, randomness. It's a complicated concept, but let me show you real quick. I think it was really clear
I think it's like
in the other group. Look,
the different possibilities of where an atom could be in a substance.
kind of, yeah, kind of. Okay, so look at it this way. So this is the juniors lesson, but real quick. They had some good graphics here. So here are your 3 states of matter, right?
No.
Okay, think about order. Look at the particles and think about order. All right. So you got your particle view of a solid. They're all nicely packed together, right? They just vibrate in place. They're pretty fixed. They don't really move much. Then your particle view of a liquid, they slip past each other, but they're not bouncing around. Then you got your gas. They're kind of bouncing everywhere, and they'll expand or compress based on, you know, how much space is available. So then you get this. Here's your solid. The particles are tightly packed. And then what happens if it gains energy? Okay, if it gains energy, they're starting to vibrate faster and then expand. So the order, if you look even at the graphic, you can see is starting to get less orderly as more energy enters the system, right? You start with these nice little barely moving things.
There's more space in between them.
Yeah, kind of, that's part of it. And then look what happens when they break free of one another. So solid begins to expand, and once it reaches a melting point, the particles break free. So now you have less order because they've broken free. So here's your liquid. Now you're in a liquid. So you've gained enough energy to go from solid to liquid. And here at liquid, they're close together, but they're moving freely. And then as it gains energy, the particles are going to move faster, right? And then as it gains even more energy, they're going to break free of one another and just totally spread out like, woo, they're gone. So yeah. So that, does that kind of help explain it? Does that give you a visual to work with when you're talking about it or no?
Yeah.
Yes, no? Cole, yes, no?
Yeah.
Yeah, okay.
I'm not the one who does it. Yeah, it's only-
So here we go back to here. So an S with the superscript 0 is your standard entropy, and your delta S is changed. So if it's positive, your increase in entropy, that's what it means. You've had an increase, right? And much, huh?
Never mind. I'm gonna stop.
No, say what you said. I just didn't hear you. No, you're right.
I was saying for Gibbs energy.
Oh, no, you're headed the right direction though. All right, so if it's a positive,
Stop talking.
no, you've had a positive change in entropy. That means you've had an increase in entropy. And that's more likely to occur as it allows for increased organization. And then if it's positive, you get a decrease in entropy. All right, here's where you were headed, Abby. Here's
This is a
Gibbs.
helpful equation
It's a helpful equation?
for this.
Mm-hmm.
Yeah, the V equals H.
You're really gonna like what I'm gonna have to tell you about midterms then, I promise. I'm not being sarcastic, I'm being serious. You're gonna like it. Okay.
Can we get a formula sheet?
Yeah, you're gonna love it. All right, so Gibbs energy. This is energy associated with a chemical reaction that can be used to do work. So the free energy of a system is the sum of its enthalpy, which is your H, right? Plus the product of its temperature in Kelvin and the entropy of a system. All right. And it predicts what, Abby? You said it earlier.
Spontaneity.
Spontaneity. There we go. So if the Gibbs energy is negative, the reaction was spontaneous. A spontaneous reaction, yeah.
What did it mean? Because it said when it was 0, it was at equilibrium. What does that mean?
So equilibrium, so think of it this way. That water right now at standard temperature and standard pressure, or that water even better because there's no ice in it. It's at equilibrium right now because it's not shifting. The phase isn't shifting and there's no reaction going on. Well, that ice now is not at equilibrium, right?
Yeah.
That makes sense?
Yeah.
So there's your formula that you liked, Cole. This one?
Mm-hmm.
All right.
Rather helpful.
Right. So entropy and enthalpy determine Gibbs energy. There it is again. So it's a change in free energy equals the change in enthalpy, and then your temperature change in entropy, right? Okay. So let's see what we got. Got your notes out?
Yeah.
See if we can get some answers. And there's not too much of this stuff on the midterm anyway, because we barely touched it before you're going to end up taking the thing. So, all right. Oh, you got your notes?
Yeah.
Ethan, do you have yours or do you leave them at home? Or?
I
All right. So the property of a system that makes a process occur consisting of two driving forces, a tendency toward the greatest what state, and a tendency toward the lowest what. So systems want to go towards the greatest, right, and the lowest enthalpy, right, or energy, right. Okay, so because the enthalpy is more of the change, so really you want energy there. All right, so the quantity of entropy, because that's by 1 mole of a substance, what do we call that?
Molar entropy.
Standard entropy, yeah, or, yeah, right. Okay, and what was the symbol for entropy was the S, I just bumped it,
Yeah.
right, and the units are,
Joules per Kelvin.
there you go. And then it's the same for molar heat capacity. The thermodynamic quality used to predict whether a reaction will occur spontaneously is
Gibbs energy.
Gibbs energy, and it's defined by G equals what?
H
H
minus
minus
T.
There you go.
Or T times S.
Right, T times S. TS is fine, you can say it that way. All right, so then for the next section, a reaction is more likely to occur if the change in entropy is what?
Positive.
Positive, good. And the entropy of a substance increases with temperature. Right, okay. So what has greater standard entropies than liquids?
Gases.
Yep, and what have the most freedom to move, so their standard entropies are the greatest? Gases again, good, all right. So what do we have for 9?
Is that
At
equilibrium
what?
zero? We didn't know. But-
Absolute 0.
Oh, okay.
So if you think about it, you got no entropy at absolute 0, because what happens at absolute 0?
Everything's frozen.
No movement, right? So if you have no movement, you're not gonna have to worry about order. Like you got nothing going on. So your entropy change of a reaction is a standard entropy of what? You get that one?
Products minus reactant.
There you go, good. And because the atoms in a diamond are in a more ordered state than graphite, the change in entropy in changing graphite into a diamond is what?
Less.
Negative, yeah, that would, you're on the right track. That's the right idea. All right, now, next thing we need to discuss. Be sure you've turned in anything that you needed to turn in for today. But here is my suggestion for you all. I'm putting up the midterm topics. Are you all right over there, Cole?
I'm laughing at him.
Nah.
We should pull his mask down, bro. Glasses with it.
Always mad because it was like this.
Can y'all turn that iPad a little? It's kind of looking half into the kitchen. It's like, yeah, it may not want to go very well. I don't know what's up with the thing. It's been really weird lately. Oop, see, I don't know what that is.
Nice one, Michael.
Oh, quick before it. Good catch. That's okay.
Didn't break though.
Yeah, here, just
Second time today.
here, hand it to me. I don't know why
Believe
it's
it or
doing
not.
this today, but it's being, just unplug it. It's something happened to my stand, I think, which is not great.
Didn't break.
That's pretty weird, man.
Mhm. Let's look at y'all like this.
Oh, yeah, okay.
All right, so
What?
You're making cold brain.
these are the topics. Okay, so you're gonna want to really pay attention. These are the topics for your midterm exam. Here is what I suggest you do. First off, the copy of this is in your homework for next week's assignment, because your homework from this week to next week is to go over your study packet. So this is your study packet. So it's actually, yep, see what it says? So it's actually online in the assignment. So if you go to the homework assignment for next week, there it'll be, okay? And what I suggest you guys do is employ a little teamwork, go into the forum, and I think I'm gonna actually start a post for your group and for the other group. And look at the number of topics. I didn't count for you guys. Hold on. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20. There's about 28, 29. So if all of you in the class, including Alex, who's online, and everybody who's absent, takes 2 to 3, you should be able to coordinate and consolidate data again. but basically for the sake of studying. So if you look at this is how you do it if you're in like a big study group for college or a AP class or whatever. You go, okay, well, I'm going to cover the first two, you cover the next two, you cover the whatever, right? And then you let everybody, I don't know what's up with this thing. I'm about to just give up. I am going to leave on it. It doesn't want to participate. Pick 2 or 3, right, that you want to cover, and you go, you research them, you come up with all the information you think is important, and do it early, and put it in the group. And that way everybody can see it without everybody having to go back through a whole semester's worth of notes and find every topic. Now, if you want to do it that way, you want to go over and do it all yourself, do it that way. Sometimes people learn better that way. Sometimes it's helpful to have everybody take like an administrative role and gather the information. Okay. So for example, like when I say branches of physical science, that's your first topic here. I'm not telling you what kind of question I'm going to ask, but we did cover what they are. So for some of these, I got specific, like scientific notation. I said, be able to make conversions. That's what you're going to want to do. And then you have precision versus accuracy. Isotopes, what are they? Historical anatomical models and the people who created them. Some of these topics are going to cover more than one question on the test, right? Like maybe I have 2 or 3 about people who created models.
Can I ask how many questions are on the
I
test?
think yours is 50. Yeah. I'll double check it though.
How many written answers are there?
I'll tell you in the end. I got to take it off and double check it. It's not too bad. So you will have mostly multiple choice, then you will have true and false, and you will have some short answer, and the extra credit is labeling. And some of you already have other extra credit too. So yes,
Just wanted to say your mask looks massive in Zoom.
it does.
It always-
Yeah. So
Helpful.
branches of physical science, scientific notation, be able to make conversions, precision versus accuracy, isotopes, what are they? Historical anatomical models, people who created them. Current, not anatomical, atomic. Current atomic model. Wow, that one just fell out of my mouth. Current atomic model, moles in reaction, moles in relation to mass and atoms, be able to make conversions. So that would be everything from like mass to moles, atoms to moles, atoms to mass, all that stuff, right? Y'all all right over there, you goobers?
Are you
Okay.
a goober?
Oh, no, they're just goofy. Hund's rule, Pauli's exclusion principle, off-bell principle, photoelectric effect, octet rule. Mhm. 3 types of experimental variables. Modern periodic table, what, who, how arranged, identify, like understand how it works. Groups versus periods versus where you find the information. If you were to see a number, what does the number mean? Right? Yeah, exactly. But if I show you one, would you know what it means? And then molar mass, be able to determine. So that one is specific. Molar mass, be able to determine. Ions, ionization energy, ionic bonding, ionic compounds. So if it says something like that, maybe this person who's doing this research wants to do just that one because maybe somebody else has a really small one. See what I mean? Types of chemical bonds. Chemical reactions, types, parts of an equation, and be able to balance, right? You're gonna have to balance. Percent composition and empirical formulas. I put both of those in the same sentence for a reason. Think about the relationship between percent composition and empirical formulas. Stoichiometry and yields. I put those in the same sentence for, well, whatever phrase for a reason too. Molar heat capacity, enthalpy, equations, symbols, calorimetry, and entropy. But you'll notice that, like I just told you, we're not going to get overly specific about those because we just touched them. Metric units. Remember the metric units? Lewis dot diagrams, how to create them. 5 laws of stoichiometry. Hypothesis. What is a hypothesis? Be sure you can explain that. Yep. And for the love of all that's holy, you have to be able to tell me the difference between scientific theory versus scientific law.
What and why and how?
Yeah. Signs of your chemical reactions. There are more than the number I'm going to require you to list. So there are more signs than the number I'll require you to list. And then settled science, which goes all the way back to lesson 1. Now, here's why you're going to like me. You can have one 3x5 card. If you don't have an index card, cut it out of a piece of paper containing only your own handwritten formulas. You don't go printing them out. You have to write them yourself. They have to be yours, handwritten, formulas only, none of the other stuff. No vocabulary, no other information, just formulas. And you have to show it to me before you start your exam. Like, this is my card. Is everything on this okay? Right? So once you have that with you, you can use it for the exam. Don't know if I'll do that on the final, but I'll do it for the midterm because it's helpful. There's a lot of formulas. We've gone over a lot of formulas. And if you can, if you understand the concept of everything, that's more important to me than if you remember every little tiny bit of detail about the formulas, because that's ubiquitous stuff you can look up at any time, right? If you need to know the formula for something, you look it up, but you need to know what the something is. And the something is more important to me than memorizing the formula. Yeah.
Two things. How much will this count towards our grade?
So that's the interesting thing about midterms. They count like a test.
Okay.
So they count like a test, but they feel different. And I do that for a couple reasons, because
Gets you nervous.
That's, on purpose. Because most of you guys haven't had the experience of taking a big test, right? And I want you to have the feeling of that without major, huge damaging consequences if you don't do well, though I think you all will do fine. Because it's important for you to know how to study for something comprehensive like this that covers a whole semester. And it's important for you to know that feeling and not choke. So these are different in that they're not online. You're going to roll all up in here week after next, and I'm going to hand you your test, and you're going to take it to a quiet place, and you're going to do it on paper. And then I'm going to grade it on paper, and I'm going to give it back to you. And it's going to feel different than anything else you've done. And I do that on purpose. It should feel weird. Yeah.
And also, looking at the lesson 16, it says lab 14 at the top.
Yeah, a couple of those are like that. That's a brownie point.
Okay.
There you go.
Like something didn't add up here. It said
Yeah,
lab 14.
yeah,
But he's
yeah.
saying-
On one lab where it said like lab 12, lab 14,
Yeah, I'm like,
or lab,
I just went to
or two
16.
lab 12s in a
I thought I
row.
put my lab in the wrong place. That's when I was like freaking out, but it's just not.
Yeah. So what we're gonna do next week is games, and more games. We may even fall into lab a little bit. If we wrap lab up, we'll do some extra games, but it's all gonna be study games. And I'll probably put you on some teams, and we'll do maybe a Jeopardy or whatever else. And
you choose.
yeah, you try and get as much. Yeah, I want to be a team captain. So we can try and get as much review as we can possibly get. I really want you guys to study hard for it. I want you to know what that feels like, and I want you to, it's that feeling is a freaky feeling. But did you just inhale that?
No, what?
What happened?
No, that thing. These
That
people are.
was really weird. Anyway. Okay.
Y'all made this look way weirder than it was.
I'll tell you how many questions. Oh, wait, let me, that was that. Okay. I'm gonna take it off the TV, and I'm gonna take it off share so that I can answer your specific questions about. Okay, so that's off the TV, right? Yes. All right, now I will go down there. Oh, I know. Okay. Let's go down there. Webos. All right, I will tell you how many of each kind of question, okay? Because y'all want to know apparently. 2 seconds.
A new bicycle.
And that's here.
A new bicycle.
All right, so your midterm will have, okay, you got 2 pages of multiple choice and true and false. So your multiple choice plus true and false is going to come to 35 questions.
Is it 25 short answer?
Hang on. So wait, these are 35 and they're a point each. All right. Then you have a page with diagramming and some fill in the blank kind of stuff. Balancing equations, matching, those are going to be 5 apiece. And then you've got like one more of those, which brings you to like 45. And then your final 5 are, let me see, hold on here. You got 1, 2, 3 short answer, and then 2 more math problems at the end. So you've got 2 big math problems at the end, 3 short answer, whole bunch of stuff in the middle with,
How many sentences is short answer?
it depends on what you're saying. But I mean,
But assume
How
not a
much
lot.
do you want?
how do you, it depends on, I mean, really, I would think a short answer could be as short as 2 to 3 sentences. It could be as long as 7 or 8. I mean, it really depends on how you're
How
going to say
thorough
it.
you decide to be.
I mean, are you going to write,
A plus
this
B.
is science.
Yeah.
Science is fun. Science can be hard, instead of, this is science and it can be fun, but also hard. 3 sentences to 1 sentence.
Especially now.
Yeah. So, and then you will have a periodic table attached to it, and you will have the extra credit, which is, you can get up to 5 on that. It's
As
like,
in you're
it's a
allowed to use
labeling.
the periodic table, you have to fill in the periodic table.
No, as in you're allowed to use it. It will be attached.
Those are-
A complete periodic table is attached. I'm not gonna make you guess that because that's
Uh,
really mean.
Yeah,
is
for
this-
like the percent
this
composition,
J
that would
Yeah, that would be really
be almost
difficult.
impossible.
It's not hard,
Mhm.
you just go through and make every combination.
Yep, yep. You have one kind of minor or 2 kind of minor math problems in the middle where you have all the matching and random stuff, and then 2 big ones toward the
Are
end.
we allowed to have a calculator?
Yes, if you need a calculator, you may have a calculator. If your calculator is your phone, I'm going to have to trust you that you're not looking things up and that you're only using your phone.
Right.
So
Wind is cold.
somebody also, you might want to designate a person to be responsible for formulas. Like,
Thanks,
let's
Paul.
get all the formulas together. You know, if you're gonna do it as a group, it might be a good way to go about it. And
You're a great part of
I
the
was
team.
gonna say one other thing about that, but I don't know where it went. It distracted me.
You're in charge of everything math.
Oh, here's what I was gonna say. Most of these answers will come either directly from your notes or from the PowerPoints, which are all available to you. So you should be able to find everything. You know, if you want to be able to copy and paste something, it might be easier to go to the PowerPoint for whatever that lesson is and copy and paste it rather than go to your notes and retype it, right? Which is why I use the PowerPoint too, because I copy and pasted it into your exam. So a lot of them are word for word and some of them are not. But you guys, I'm not worried. You guys are gonna do just fine.
And it is next week or the
It is week after. So next week is just
review?
review. Yeah, and I told the other group, I thought we were reviewing through lab, but we're not because we have that other lab. We may review if we wrap that up. So I need to clarify that for them.
Soft drinks. I don't know, read the side of the cup.
So for that lab, we're gonna make our own hydrometers, and it should be kind of fun. It's a little DIY one. Yeah. So we actually have like a nice glass one because my husband does homebrew. So we actually have a nice glass one, and
We
it's,
let you use that.
no, we're not using that. You're making your own. But it's kind of,
We're making these out of glass one.
no, it's cool because so in this case, we're using sugar. We're finding out how much sugar is in different solutions, different drinks, right? But when we use it for brewing, we find out how much sugar is there for the purpose of doing the calculation that tells you how much alcohol it will produce.
I like the little like water straw thing that sits on top
Mm-hmm.
that lets.
The bubble, the airlock, it's an airlock. It's a U-shaped, well, it's a tube that goes up and makes a bend like that, kind of like, you know, how a toilet has a U-bend. It has a U-bend in it, and the U-bend is full of water. And then as the yeast does its work in whatever, like down there at cider right now brewing, it'll produce gas. And when enough gas gets enough pressure, it pushes up and then down through the water and makes a bubble that pops up the other side, but it keeps it from allowing junk to get into your stuff, right? All right, so here's what I'm gonna do for the next couple minutes. I'm gonna put up the lab video. I'll skip over all the steps in the middle, but I'm gonna put that up so that for the sake of understanding how to make sure you can do all the calculations, right? So that you can get that turned in. So let me grab that real quick and then we will.
Ethan, you studied for the Spanish test, right? No, there wasn't.
There is no Spanish test.
Y'all are
Oh, thank you.
so mean
Oh, my
to each
Lord.
other. It's unreal.
Ozzy,
Ozzy!
you're not scary. Stop.
I just gave him a heart attack. Yes,
I'm a boomer. You can't do this to me.
You're a boomer?
Yeah.
Are you sure?
Yeah.
Whatever you did.
All right. I gotta go back to sharing. I took it off share.
Dude,
Hold
you
on.
scared me so bad.
That was
You
funny.
almost got to that hole by falling and I can't get
That was good.
Like literally, I was about to be like, oh god, Abby.
So Alex, if you've already watched this, then you're good.
I can't get up.
But this is for everybody else. And
Yeah, 'cause
I've
that's the one-
attached that sheet to the lab so you can complete that and turn it in. All your data will be the same as mine. Interestingly, those groups using glass thermometers got numbers very similar to mine, and those groups using the CBL electronic device got much higher numbers.
Everyone but Michael's group.
Yeah.
And
Everyone but
Bailey's
Michael's
group
group.
partially because.
The only thing I don't have is the
Yeah.
heat in kilojoules.
Okay, well, this goes over how to get it. So
Oh, your fault. I got one.
You didn't like that song.
it works, man. Oh, but you have to see my intro was so cool. I have this dude. I did animation. It was fun. Watch this dude. We even did sound effects. Drew and I had fun. Yeah, hang on. He's coming. He's cool.
When the substances were mixed, the container shattered, sharing the contents onto the workers' arms and legs.
Yeah, it was fun. We had too much fun. So
He looks like.
he's mad, man. Stuff blew up on him. I'd be mad too.
I'd be more worried about the shots of glass being shot at him.
That's true too.
I'm guessing that since we couldn't prove that he, I'm guessing
Oh,
because
no.
we proved that
Mom, you
he
just turned
didn't
his
get
light off.
burned, he's getting perjury.
Mom, your light is on.
I can't. Oh.
No, what time? 8?
Yeah.
Yeah.
Hey, we can get the boss a voice. We had fun. We got a voice changer app. Drew and I did.
Yeah.
Can't hear it very well this way, but it's there.
It is.
All right, so here we get to the
Keep
answers.
looking at
It's
it.
not as little as he was, because when he was, his arms were super loose and you could shake him and then do this. It's just.
Do-do-do-do-do,
Wait, hold
Yeah.
We only got one in the part.
Okay, here's what we
I'm
did.
really confused. They both say last one.
Yeah, that was a, we caught it. You guys got your temperature change, right?
It's grabbing his mouth.
So what was the initial starting temperature of the water? And
No,
what
what do you do? Like, I have
as
nothing
we're adding the sodium hydroxide. Initial temperature was next to the side. The final is the fourth.
I think you guys got these steps, right?
What were the temperatures of the one?
These steps were good. It was when you got to, where are we? There you go. We use a mass of water.
So we will divide our page up into 3 sections, one for each reaction. Here in each section, we will include the equation, L delta T is 6.9 in the first reaction. And then we will use our equation, E equals mass our first reaction at 2.9
And I'll pause that for you guys, since that's the equation I think you guys were needing, right?
What is it?
Where is it?
What?
What is it?
What?
Question 10 years from now.
Wow.
Yeah.
Can you read out the?
So you're using heat equals mass times delta T for reaction 1 times CpH2O, so specific heat of water, which becomes
Mass times delta T.
times CpH2O, the specific heat of water.
Will this be in the email?
The video, yeah.
This one? This video?
Yeah, well, that's already there. It's attached to the lab. All right, so then it becomes heat is 100 grams, because that's your mass,
No.
times whatever your delta T number is. Mine was 6.9 Celsius. Yeah, you got to do all three separately. And then the specific heat of water is 4.180.
Always?
Mhm.
Oh.
Yep,
Four.
joules over grams degrees Celsius. And you end up being able to cross out your grams and your degrees Celsius. Because you have 100 grams. See, look
Yeah.
behind you. You see it?
I didn't get the last two measurements.
Okay, so we'll
Temperatures.
yeah, we'll consolidate data. You can.
I'm gonna have them.
Is yours still up there doing its thing, or it's probably gone up and down already?
I don't even know.
Yeah, we probably missed the high one. Yeah, you got all three, right? Okay, so Michael got all three.
I don't think anyone else did.
Yeah, and so the thing is, Michael's information then is going to be what you're going to want, because your data won't make sense combined with his. Like, you can't combine his data with your data. You're going to have to just use Michael's data. So whatever Michael's data is becomes the master data for the class, pretty much.
Do it.
So then, checking time. All right. Z.
All right. Okay.
Oh my gracious, he thinks he's a beast. So then that gives you joules, but you need kilojoules. So you just gotta scoot your decimal, right, and convert that.
It won't count.
Look how scary he is though.
Can we get his ears off for tubbing?
Yeah.
Let's see, can I make it any bigger?
He's
Dude, if I was scared of you, I wouldn't do this, but I do it.
There we go.
His ears off.
Yeah.
Y'all see that? Y'all wanna probably jot
Run
it
around
down
outside,
somewhere.
like that.
Like, don't know if I saw the steam 8 years prior.
Oh, they're all yelling.
I can do Jeopardy music to pass the time. It's
There you
the
can.
One song I know.
Oh, there you go. All
That's gonna make
right.
me sad. Don't put Jeopardy.
Oh, yeah.
Oh gosh, did you see the first episode after he passed, but they've already recorded 30 some odd ones? The intro, the cult, so they do that cold intro like they do on SNL or whatever, where somebody comes out and talks. So it was the producer, and he came out and was like, he said that they'd already recorded 30 some odd episodes, and Alex Trebek had requested that they air them all regardless. So he came out, and the guy actually got choked up. He had this nice statement, and he got almost to the end of it, and you could hear him. I thought, oh, this is so sad. But they were talking about what's his name? Reading
Oh, the
Rainbow.
new guy?
Reading Rainbow.
Or reading Rainbow.
LeVar Burton doing it. And I was like, oh, for real? I will watch it now for sure.
Reading Rainbow.
Like 7 o'clock and 7:30 for some people's houses, and like
Jeopardy's
best
fun.
time of the day.
Yep.
It's like Wheel of Fortune, then Jeopardy.
Yep. So you guys have that? All right.
Like Wheel of Fortune, an average person could do, but like Jeopardy is like a whole
Jeopardy, you have to think.
knowledge thing.
So then after that,
The knowledge thing. That's
One letter off.
you just end up with how much heat did you produce in each reaction.
Action 3.
Ba-da-da-da-dum.
I love the dramatic music. It's
Well,
like,
at delta T for reaction 2, it was obvious it was the warm.
No.
So there we go. And we came up with not enough heat evolved to cause a burn.
So do we, wait, what was the total heat
said,
for the
yeah,
other
you
two
take
reactions?
So it's the same equation
Mhm.
you have to do for reaction 2. And whoops, there's my judge. He's mad. So anyway, yes, you have to do the same equation with the data from, come back.
It looks like South Park.
It kind of does.
That's why I thought.
There it is.
I was like,
So it's the same equation you have to do with the data from 2 and 3. And you'll get, so I had 2.9, 2.1, and 4.6. Those are my answers. Whatever Michael's answers are going to be the right answers, though, for everybody else. So
Michael, you can't get it wrong.
get it right,
We're
Michael.
all counting on you, Michael.
You just let us know when you're done.
Yeah, tell everybody when you're all finished there, Michael.
No pressure.
So then what I think I'll do for you guys for the next little bit, and this is what I was hoping we'd have time to do, is give you all time to start some midterm crunching, like some midterm deciding who's doing what, like if you're doing it that way.
Hey, Cole,
Or
you
if
do
you're
it for me?
not, just kind of pick up from wherever.
Hey, everyone do it for me or am I giving you log answers?
There you
Whoa.
go. Oh ho ho, listen to this. Okay, now not 2 weeks ago, the lab with the gravimetric analysis. I returned it to most people who turned it in because most people had my answers instead of their own answers. So I don't know if you guys got it turned in today. Hopefully you did. If not, I may give it another week just to make sure everybody understands what's going on because it was
The what?
holidays. The gravimetric analysis lab,
13 or 14?
it's 13.
I
14 was the
returned.
stinky one. That lab was unbelievably smelly.
Which one?
The
Oh,
cigarette lab. Oh my gosh, I smelled it for days, y'all. Days. Even though I had already cleaned up everything, it was stuck in my head for days, that smell. Those were the cheapest, nastiest cigarettes.
I sent that lab 13 in with the email of lab. 12
Okay,
that I
yeah,
had.
then it's probably sitting in my little file.
And I think, and
Bless you.
I think I turned it in via
You went to
teacher.
eat. What?
Or
Okay.
Like, are you good, homie?
one of the two. I think it was teacheries.
Okay, all
What?
You cannot touch me.
right, good.
Trying.
All right, so what I'm gonna do is I'm gonna put this back up with your, here we go. Actually, I'm just gonna put the sheet up. It's easier to do it that way, I think.
Okay, what's joule to kilojoule? Is it 2 kilowatt?
Joule to
Decimal.
kilojoule.
To the right, right?
It's, well, a kilojoule is 1,000 joules.
Oh, so it's
3.
Yeah, 3 to the right.
3
Or no?
to the left. You move it 3 decimal point. You move the decimal point 3 to the left.
Left, very good. All right, let me see, I'm gonna pull up your,
Because if you move it to the right, you make it larger.
Yeah.
But moving to the left, you make it smaller.
Yeah.
And you want joule to kilojoule. So, yes.
but that's not it.
So I have
Put it in your
1,000
folder.
joules. And I just turned it into 1 kilojoule.
All right, so I'm gonna put your
Okay.
classes, study stuff up here and let you guys start dealing with that. So I'm gonna leave Alex on here in case she wants to chat with anyone. And maybe make some suggestions about what she wants to do. Where is she? There we go. I'll open the chat in case she chats. Y'all can see that. Let me scooch all this over. No, okay, fine. You're so mean, Cole.
You animal abuser.
Hey, does he look like he's being abused right now?
Not so much.
I'm lying down and crying. How dare you? How dare you?
Can I get
Yeah, I
this? I
finished the lab.
can't
You guys done
see
yet?
it. God, it does
We don't
that.
have any answers.
Okay, now come on.
There's not any real good
Mm.
ones.
Come on. Okay. Actually, I'll stop the video. My video, maybe that'll help. It just doesn't want to move over. All right, do your thing. Okay, so here's Alex.
Yellow, look at this.
I'll put her here. Then I'll do,
You have to like really muscle. He'll stand there and you're like, You get the right angle on the little wood, like if you were bigger.
Do this way so that you can see her at the same time,
Seriously,
hopefully.
like, if he was like German Shepherd size, I'd be scared of him. He's not.
But he's like, he's barely above your ankle, I guess.
He thinks he's big though, that's his
Yeah,
problem.
he's got the attitude of a German Shepherd.
Ooh.
He has the attitude of a Rottweiler.
Well, not even actually, because the bigger dogs don't even have bad attitudes.
No,
They
they
understand
don't.
how big they are.
Mhm.
Very good boys. Small dogs, Chihuahuas are the devil.
Yeah,
though.
Chihuahuas are ridiculous.
Okay, so here is, you can see hopefully now all the things you need. Here is a chat in case Alex decides to chat. And here is your, you can, I think, we have to scroll a little bit, but,
I'll do the first 5.
so take notes and decide what you're doing. You can go up there if you need to, yeah, do whatever you need to do.
Take a look.
Alex investigates.
Me and Cole do
Alex
the first thing tomorrow,
investigates.
and we'll see how much you guys have done.
You show
Yeah,
her.
come on.
We'll fix it in the class.
Here it is, if you guys here want to look at it.
What do you call it, Mom?
I'll put you down.
I've already
Good
been.
job, Cole.
Hey,
I
thanks,
just
Cole.
said good job.
Hey, Cole, just wanted to tell you good job.
Thank you.
Nice work, Cole. Nice work.
Yeah.
All right, Alex, so you can hang and chat with everybody and tell them what you want to do if you want to do this part, or you're free to go otherwise, because this is just coordinating now.
You gotta do what
All right.
you gotta do.
And for you, Alex, and anybody else who is absent,
This is the lab.
anybody who is, yes, that one needs to be turned in, and today's homework, and this one that we just did today by next week. Anybody who's absent or cyber, when it comes to the midterm, it will be sent to your parents as an email. They will have to give it to you and time it. Oh, you get an hour. You won't need it. An hour. You guys have longer than 1 hour, I think. You guys won't need it.
I need to turn this in?
Yeah, if you have your data. If it's your data now. If it's not your data,
I believe the
Oh, yeah,
video.
I don't need this. I don't need this.
your data, not my data. I know what my data is.
Well, all of it's mine except for the stuff that I couldn't
Michael.
get with the last two.
What?
Because we never were able to weigh the last two. So I
I
just,
gave them to you. I sent it to you in an email. Sent it to everybody.
yeah, that was in the video.
Just, yeah.
I really like coffee.
No, sent it to you all in a separate
I'll be
email.
fast.
Oh, no, I did write it.
Okay.
When you get-
Definitely not something.
Sure, it's fine.
I turned it in and I'm like, someone else is like, that's a different answer for me.
It's okay. No.
Hodor.
50. You go here.
I'm assuming this is what we need.
Bro.
What is it? I didn't come up with that, thankfully. Thankfully, yeah. People came up with some.
It's the furries, man. That's
Like,
it.
Yeah, just blame it on.
Yeah.
No, literally, just blame every problem that you ever have on furries.
I was wondering what you were doing. That's frighteningly good. Wow. Beautiful. Am I that lovely?
You drew that in class?
Yes,
How?
because she's singing. That's what she does. That's just stunning. Look at that. Thanks, Sid. I don't know how you do that. I need you to help next time I have to like paint on a cake, because sometimes it's frightening. I can do 3D all day long. You know, sculpt something, no problem. But this kind of 2D, wow.
Team, why'd you give me Team Blue? What the heck? That's Cole's. Oh my gosh. Cole.
Okay.
Yes, sir.
This is Lily.
Oh, yes. I'll take her stuff and go put it in her folder. I got it. Hey, can you bring up whoever dropped his glove on the floor?
This is.
That's fine.
I'm both negative 50 points. Easy. Negative 20%. No shit.
Hey, you got homework, right?
What? Yeah.
Was
It was homework.
Was
It
it
was
just the
test.
project? Okay, yeah.
Okay, let's see.
Is this finished today?
Yeah, I hear her talking upstairs. I gotta try and fix this thing for her because this is a nightmare, whatever this is. I don't know why this isn't working.
I use close off.
Yeah, something's wrong with my tripod. I don't know why. It's been very reliable. Now,
Oh, you got it, good job.
ears are always falling down.
Oh, come on, go, 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 go.
Okay.
No, when he goes fast, he goes fast. Ozzy, let's go. Get it, buddy, go, 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 go. Tired already?
He's just staring at it.
Like, I will not entertain you people.
This is what I don't understand. This is supposed to work.
Oh, wait.
Noah!
That's my fault. Good job! You did it, good boy!
There it is.
Good job, you got it. You did it, boy. You did it, good job. Good boy.
Oh, for goodness sakes, are we for real? Oh my gosh, the handle.
What's the new list?
No, I can't undo it all. The stupid handle broke. Are you serious?
Whoa. Good.
Does your dad keep all fun camera equipment at home, Abby? Does he have that kind of stuff?
Some stuff he does.
Yeah, we've been using. Actually, I really need to find out if he knows my friend Scott, and he doesn't, they should know each other. They do the same stuff, or a lot of the same stuff. But we've been using all of his stuff for all of our church videos, so.
Yeah, because I saw this tweet, yeah, when they added.
In my way, Mom said in my way.
That probably means on my way, yeah. In my way, on my way. Whatever. I'm in my own way all the time.
Have you seen this?
More often than not, I think I'm in my way. Okay, I'm gonna stop because Alex isn't commenting, so I don't think she's.
They gave a teaser. I know, but I put the link and it went to the. Oh my God, this is gonna be chaos.